Hello there, I'm Saem. Today we'll be solving May-June 2021, paper 441 of Computer Science, 9618. So here we go. The duration of this paper is 2 hours 30 minutes. I'll be solving this paper in Python. Okay, so that's one of the most preferred language and the most popular language right now in 2023, and will be there for the next few decades. So obviously, one should be, you can Google up yourself, you can find yourself out, type in the top programming languages 2022, 2023, you will find it yourself. So I would always suggest that you always remain in the top 3 or top 5. Okay. If you go below top 5, the languages will be obsolete in the years to come. So there's no point of learning such kind of languages. Okay. So open document evidence.doc. So, okay, right. Make sure your name, surname, and number. Okay, fine. Save your evidence document. So obviously you can copy and paste all the code in the evidence document. I'm just going to solve it with you. A class declaration can be used. We will be using a class declaration can be used to declare a record. A list is an alternate to an array. The source file is used to answer question 3. The file is called treasurechestdata.txt. I will right now just solve question 1 with you. The rest I will do it afterwards. Okay. An unordered linked list uses a 1D array to store the data. Each item in the linked list is of a record type node with the field data and the field next node. Okay, right? The current contents of the linked list are starter points, empty list 5. Then we have index from 1 to 9. We have data, and we have the next node. Okay. The following is a pseudocode for the record type node. Type node declare data, integer, declare next node. So we have data, and we have next node, which is basically an integer. It's a number. Okay, and type. Write a program code to declare the type, the record type node. Okay, so this is what we have over here. Okay, right. So let's start doing this. So write program code to declare record type node. So we have data and we have next node. So I am going to make a new Python file. I am going to name it as June 2022 question 1. Okay. One I, I'll name it. Right. So I'll keep on going back. So right. Okay. So how can we declare? So obviously we will use over here, we'll make a class and we'll name the class as node, right? And we have to define is a constructor in it. I'll just explain the code. Let me just, so we have data and we have is next node. Okay. Right. So okay, we have data and we have next node. Okay, right. So we can write over here, obviously, yes, self data and self dot next. Is equals to next. Number. Okay. We can even name this as, we can make, because obviously it's a number, so let it be number. So this is what we have. Okay. So we have made a class. Okay. So we made a constructor self, the data and next node. So obviously what we're doing is we're defining data, the data, data and next node. So this is simply the one way in Python that you can declare the type node. Okay, right. So next what we have, write a program code for the main program. Declare 1D array declare a 1D array of type node with identified linked list and initialize it with the data shown in the table on 2. Declare the pointers. So you have to declare the pointers. Okay, we have to declare 1D array. So let's declare the pointers and 1D array. Save your program, copy paste the program and the document. Okay, so what I'll do now is I'll just I don't have the file. It'll take me just some time to find the evidence file. So meanwhile, I'll do it afterwards. Just question 1. Next we have is, which part was it? Was it? Yeah, copy and paste this. Part 1A. And B part it says, so what we can do is, so we have to make over here 1D array, which is a linked list, and which will be the following. Okay, so, okay. So we'll have over here is linked list is equals to, we can define this, obviously, we define it as a list. So we'll put the square brackets and we'll have node. So we have 1, 1, 5, 4, 6, 7. So we'll have over here is node, first of all. So 1, 1. I'll just paste it afterwards, okay? Right. So six, 7, 7 minus 1, 2, 2, 0, 6, 0, 8. Make sure you don't make a mistake over here. 2, 2, 0, 6, 0, 8, 56, 3, 6, 3, and then we have is 0, 9, 0 minus 1. Zero, 9, 0 minus 1. Okay, so we declare this. And then it says also declare the pointers as well. Okay, so we'll define over here is the start pointer is equals to 0 and the list is equals to 5, right? Cool. But whatever pointers have been defined over here, okay, we have defined this and we have defined these two over here. So that's the way this particular part will be done. We make over here is a linked list. We define the nodes inside it, and we define the pointers. Pretty easy, nothing much complicated. So we're going to paste in the evidence document. Till now, everything's going fine. I don't think so. It's very complicated. So here we go. We'll come to the next part. Okay, which is basically C part. So here we go. Part C. Let's see what do we have in part C. Okay, so let me zoom in more so that okay, the procedure output node. So we have to make a procedure output nodes takes the array and the start pointer as parameters. The procedure outputs the data from the linked list by following the next node values. Write program code for procedure output nodes. Okay, just give me a second. Takes the array and the starter point as parameters. Okay. The procedure outputs the data from the linked list followed by next node values. Okay. So what we'll have over here is that's the name, I believe. Output nodes, right? And we have to have where is the linked list. Okay. Just give me a second. Let me just complete and I'll explain you. Okay. Then we'll have is start pointer. Where is that not? It's not equal to -1. Print linked list. Print list. I'll name this as current pointer. Okay, that makes more sense. Okay. I'll explain you afterwards. Okay, right. I'm sorry. I'll Okay, so what I've done over here is the question basically said that we have to make a procedure that takes the array as the output parameter. The procedure outputs the data from the linked list by following the next node values. Okay, so what we've done is obviously if you look at the question over here, let me explain this. We have over here the data, and obviously what you can see over here is I have the index value 0 to 9. Okay, so obviously when we have negative minus 1, which is not a part over here. So minus it when it will come to -1, it will stop over there right away. Okay. So what will happen actually is, let me show you what will happen. So initially first we'll have 1. Okay, 1 from here. This is the next node. So the next node points to this. Okay. So this means after this 1 is pointing over here. So this means I'll have 5. Okay. Points over here. And 5 basically has the next node 4. So 4 basically points over here. And this is basically 2. So if I write the data that I have 2, so 2's next node is 2. So 2 basically points over here. Okay. Okay. Which is 6, comes 6, right? Then I have 7. So I come to 7, right? Okay. So 7 basically is 56, as you can see. 7 has 56. So 56 points to 3. And if I go back, where do I have? Okay, if this points to 3, and 3 is over here. So after 56, I get 7. But after that, I have -1. So -1 basically, I don't have an index value -1. So obviously it will stop over here. Okay, as you can see. So this is the list that will be printed. So you have to actually understand this first. Okay, you have to, whenever you get a question like this one, make sure that you try to understand. And if you have a problem understanding linked list, single linked list, or double linked list, you can follow one of my lecture in which I've explained how does linked list work. It's very important for you to understand how do linked lists actually work. Then obviously this will be a better understanding for you. So that's the same thing exactly what we've done over here is we said while the starter pointer is equal to, this is why using the starter pointer, we could have used the current pointer, frankly speaking, not the starter pointer. Let's use the word current pointer, okay? The current pointer, it would have been better word, although it doesn't make a difference. You can use start pointer as well, or current pointer as well, that's fine. But they should always have meaningful names to whatever you do, okay? Because start will just be start. And in this particular case, our pointer keeps on changing. So we always have to refer to the current pointer, what the current pointer is. What's happening over here is, while the current pointer is not -1, print linked list current pointer data, print the data in the current list. And current pointer will be from the linked list, the current pointer next, keep on pointing to the next node. So this loop will keep on going on unless and until this is not -1. If it's not -1, it'll come out of it. So to keep on printing this it will print every time, and this will take it to the next one. This will print, take it to the next one, unless until this condition not true. So I hope you got this part. So here we go. Copy this, and we come here. This was this part, right? Then we will go, inshallah, to the next part, which is C2. So this was actually C1I, I would say. I'm just increase the size of this a bit. So this is C2, CI. Okay, right. Now what do we have here? The question over here says, edit the main program, okay, to call the procedure output nodes. Okay. Take a screenshot to show output of the procedure output nodes. Edit the main program to call the procedure output nodes. Okay, now we have to call it actually. Okay, so what we'll do is So we have to actually make the main program, right? Which means the part one that we had. I'll just explain this. This has to be integrated with this part. Okay, and then with this part. So we defined our class over here. We defined our linked list over here, right? Okay. And then over here, we defined output nodes. Okay. And all we have to do over here is that we have to call the procedure. So how do we call the procedure? I'll just tell you how. So what you'll do is you'll type output nodes and linked list, comma, we have the current pointer, right? I hope I have not mentioned over here. Just 1 second. Okay. Uh, next number, starter pointer. I've defined starter pointer over here. So I'm sorry. Third time I'm changing this. I'll leave it a starter pointer. There will be a problem. Okay. So here we go. Has to be starter pointer. Just 1 second. I'll explain. Okay. So we have this. Let me just check again. Just 1 second. And right, it should work. So it should print. So if I run this, okay, just 1 second. Invalid syntax, line 2. Adios, man. So remember, this is exactly 1526, 1526, 56 hours. So exactly, this is what we did before, and this is exactly the same output that we're getting. This means we're going on a very good track. Good. So I'll just simply copy this, and here we go. We also have done this part, right? Okay. So what's happening over here is I've defined this class node, and then we define the linked list, and if we define the output node, and then we just basically called the output nodes. That's how we do it. Okay, so it's all about calling the functions. Right, let's go to the next part. And now we have is coming up D part. The function add node takes the linked list and pointer as a parameter. Okay, then takes the input data to be added to the end of the linked list. The function adds the nodes in the next available space, updates the pointers, and returns true. If there are any empty nodes, it returns false. Write the program code for the function add nodes. Okay, save your program. Right. So here we go. Right. So we have to define a function add node, takes the linked list and the pointers as parameter. Okay, so we'll have the start pointer and empty list in our parameter, then takes the input. So we will just use variable will input. The function adds node in the next available space. So we can use an if condition, okay, between 0 and 9, something like that. It will return false. Okay, and then if it's true, it adds the node to the next available space and updates it. Okay, so I'll just write the program and I'll explain you how can this be done. Okay, just give me like 5 minutes so we can def. In case there's some naming convention problem, you have to check that out yourself, okay? Because that could be a problem in the exam. So I believe you have to practice this again and again because in CIs you can have really big problems if you're confused. So P4 needs a lot of practice, I'm telling you. You really have to be a good core programmer to do this really well. Data to add enter the data to be added to the list, right? You can say is if empty list is less than 0 or the empty list is greater than 9, then return false. Else new defined variable new node can be node and data to add, and obviously since we're talking about if unless rental -1 is encountered. And what I can do is obviously let me somehow convert this into an integer. While you practice this, you'll get the idea yourself. Okay, linked list empty list is equals to new node. Right? I really like the way Python libraries work. It's really, really interesting. Okay. Then we can have is the next pointer, so 0, while the start pointer is not equal to -1, same thing that we did over there. In fact, why can't I copy it from? No, is it the same thing? Okay, I'll type it. While what we'll have is the next pointer is equals to start pointer. Start pointer is equals to linked list. Start pointer dot next node linked list we don't really have to. Fine, this is what we have. It's fine. And then we can simply have over here is return true, right? So this is the way we will be doing this particular part. Okay. So I repeat again. Uh, this is what we did. We defined a function. If it's true, else new node is it defines a new node. Add to node whatever has to be added. That's the way it has to be done. -1, obviously, because the next one we'll have is this. Okay, we'll have -1. Linked list, empty list, new node. So new node will be assigned to this. We'll just make next pointer. We'll assign 0 because we want to run a loop over here. So while start pointer is not equal to -1, start pointer is next pointer. And then what we do is we simply keep on adding these values to the start pointer. Okay, so this keeps on going on, right? So there we go, we'll paste this over here. Part. Which part was this? C2 was done. This was basically D1. Okay, right. Okay. So the next part is add the main program to call add nodes, output an appropriate message depending on the result returned from add node, call output nodes twice, once before and once after calling the add node. Save your program. Okay, right. So just give me a second because I have to type. I'll explain. I'll just pause it for a while and I will type all the code and I'll explain it. Okay, so this is the part. In fact, I have completed till 3 part over here. I'll read again. So we did this part in the right now. Added the main program. So we have to go to the main program. Okay, so add. So we have to call the add nodes. We just made the add nodes over here. Okay, we have to call it now. Output appropriate messages depending on the result. Return from add node. Call output nodes twice. We have to call it twice. I'll show you what we've done. So this is, first of all, let me show you what the output is. If I run this, this is what the output. So the question basically said over here was, let me read the question again. The test your program by inputting the data value 5 and take a screenshot to show the output. So obviously what I'll do is I'll enter here 5 and enter, and this is what I get. I get this 1, 5, 2, 6, 56, 7. Then we encounter -1, it stops, and then I call it again. So again, it gives me the following output 1, 5, 2, 6, 56, 7, 5. So 5, this is where the input is being done. This is where the inputting is done. But where are we calling? We're calling it here and here. And I'll show you where is this being called. You can see over here is that output nodes has been called over here and has been called over here. Okay. So that this is where it has been called. Now, this part, we did discuss all this previously. This one, we defined the output nodes. We talked about defining the add node where we define the starter point, two pointers. And we had 2 conditions, one if it's true, one if it's false. And if it's true, we simply added a new node. We initialized the next pointer with 0, okay? And we said that while the start pointer is not -1, the starter pointer becomes the next node, and the linked list, the starter pointer next node becomes the starter point. Okay, so this keeps on going on. Okay, right? In fact, just 1 second. I just want to check one thing. I'll just tell you what. If I eliminate this, if I run this, I add 5. Yeah, it works in the same way. Okay, so we don't really actually, we don't need to do this. There's no point, right? So starter pointer is this. then this is what I'm talking about. Call the add nodes and output an appropriate message. So this is what we've done. Return value is equal to, this is, I'm calling the add node, and I'm saying is an appropriate message. If the return value is true, print this data, else print this. So pretty easy. This is how I'm calling, and an appropriate message depending on the result returned. So an appropriate message if it's true or if it's not. So this is the way it's done. Maybe there could be an alternate way of doing it, but this is one of the most appropriate solution in Python that can be done. So if there's a problem, you can mention in my comment area, and I will be able to answer your questions. If there's some confusion, I would like to help you out in that particular part. Till then, we will be solving the next part in the next lecture to come. So see you then.